Excellent. Hello, everyone, and welcome to day 4 of Innovation Week 2025. My name is James Downey, and I'm going to be hosting today's session. And I have the pleasure of being joined on stage by several of the CubeWise engineering team, with Guido, Stephen, and Nicholas, who'll be running through with me the reasons why we want to be talking about high-tech performance tuning and testing with your planning analytics applications. This personally is one of my kind of favorite topics in that you can never have planning analytics run fast enough, and so it's how fast can we go, and kind of pushing CubeWise and pushing the innovation around planning analytics and its performance is just such a fascinating topic, and really looking forward to kind of diving deep into that with the engineering team here today. But before we kind of get into today in greater detail, just a quick recap on the week. Earlier in the week, we had the CubeWise team with Tracy Pepe kind of talking about the multi-cloud deployment options. And so that was a fantastic session. And then on the Tuesday, we had a few new CubeWisers on the call, and where we were talking about the importance of visual excellence and building user trust with the user experience, whether it be workspace or with Applico UX as an example. And some of the design principles and design efficiencies that you want to be putting in place to really drive user adoption and user trust. So that was an excellent session there. And then yesterday, Steve, myself, and Dean and Jason were here talking about the AI or Gen AI with planning analytics. And there was several kind of wow moments there where we were looking at AI agent chatbots and kind of interacting with that and getting meaningful responses at kind of like maybe a junior analyst kind of level, and kind of looking at how this is evolving and the opportunity that presents to again evolving, maturing, expanding the use cases of planning analytics across the enterprise. So that was it was a really great session. And of course, today, as I said, we're talking about performance tuning and testing of planning analytics, and that's going to be a fantastic session. And then tomorrow, Steve, myself, Nicholas, and Marius will be wrapping up Innovation Week 2025 as we do the global launch of Atmosphere. So that's going to be a great session there. Marius is going to be doing a presentation and showing some integrations with our pre-built connector. So please come and join us for that as we wrap up the week and launch. CubeWise launches its new product Atmosphere into market for global release. So yeah, looking forward to that. I guess more generally, just across the year, quick plug. There's going to be Think 2025 in Boston for those of you who are kind of in the North American region. Again, the CubeWise team will be there, so looking forward to hopefully seeing a few of you there. If you are there, please, if you are planning to go there, please reach out so we can kind of catch up. And additionally, the CubeWise team will be down in Orlando in October for Tech Exchange. So we'll be hoping to have a number of presentations, customer presentations. The Team One World Championships there, and kind of making a big splash at Tech Exchange in Orlando later in the year. So again, please reach out if you're going to be there. It's going to be great to catch up with so many of you as we did last year when I was in Las Vegas. Okay, so that's just kind of a bit of a recap and a bit of about a year ahead as well. So all that to one side. If you do have any questions, please put them in the chat or the Q&A widget, and we will kind of do our best to answer them. We had great engagement yesterday, so again, hopefully we can have something similar today with questions. We'll be sharing a number of links to different artifacts and things like that, and of course we'll be following up if there's questions we can't get to on the call. So Steve, you were talking about it yesterday. This is one of our favorite topics, performance, high performing applications. Yeah, especially at CubeWise when we want to deliver applications at scale, for the enterprise, and big data movement, and you want fast, efficient, clean movement. But before we kind of get to that, let's start at first principles, right? So do you want to share a lot has evolved since let's say the 952 eras in terms of architecture. So before we kind of get into performance, you want to let's start with talking about architecture and the importance of that. And you want to set the scene for today for us?
Yeah, Steve Waterbury, technical manager here at CubeWise. And it's a really good point, James, right? Because I've been, doing planning analytics for 15 years now. And what was high performing back in 2010, 2009, 952 era is different than what it is now. That's partially because of the compute that we have available to us, but it's also, at its foundation, TM1952 doesn't have the same capabilities that planning analytics does today, right? And there have been iterations of that, sort of throughout the history of the development and the investments that IBM has made in the platform. But, you mentioned architecture there. In order to take advantage of some of those newer features and some of those capabilities, you really have to think about, from an architectural standpoint, things that you need to be able to do within your cubes or your models or whatever in order to be able to use that, whether or not that's your user interface, right? PAF-A, and as opposed to perspectives,
Hmm.
PAW, maybe Applico or something along those lines. Or, and I'll bring Guido in just a second to talk a little bit about, some of this because I think he's probably got some good thoughts on it as well, right? But the advantages in things like, parallel interaction or multi-threading of your views. As an example, back when we were doing 952 cubes, that the tendency was to build one massive cube, and you would have, or a couple of very large cubes.
Yeah.
And part of the reason for that is, you had to, right? You need to be able to get all your data, and you'd have lots and lots of dimensions in order to be able to get the analytics that you wanted. And so you had to sacrifice some of the performance side of stuff, in order to really be able to get some of the business needs that you had out of the tool. So I don't know, Guido, if you have any thoughts on this, or some of your experiences in the past that may sort of inform sort of what we're talking about here relative to sort of this life cycle that we have from 952 to 10.2 to sort of PA today and eventually V12 in the future.
Yeah, the list you can go down there is quite long. Guido Tejeda is my name, senior software engineer. Yeah, so I worked with the enterprise readiness team at IBM for quite some time, and the evolution of TM1, particularly when it comes to the 952 release. That was really a huge milestone for multiple users to be able to write to the same cube. So before that, when you did a write operation, the whole cube was locked. But since 952, that's not the case anymore. Little fun fact here, you see the F-18 fighter jet behind me. We were out in St. Louis with Boeing for a long time, doing load runner test scripts, and parameterize those and automate them. And the runway where these F-18s would be tested was right next to the building. So we had to pause our meetings every time one of those birds would take off because it was just too much noise. Anyway, so the story here is before 952, so we engaged with Boeing, large customer, lots of users. We went there. I was tasked with, recording basically user interactions, and then parameterize them, find out, things like wait times. I mean, performance testing is complicated. We'll get to more detail on that. Um, and then we had a pre-release, obviously, that was not publicly available uh, for all customers yet before 952 came out. So we went back to the lab with those scripts, we tested, went back and forth with Boeing all the time. And then we had that breakthrough, right? Introduction of parallel interaction. Great step. So we went back to Boeing, we ran the tests, and they performed great, just to find out that now TM1 Web was actually the bottleneck. So we had to put that behind load balancers and scale that up. So you just get a glimpse of many different areas where performance can, or some component can in your architecture can bottleneck you. And I think Nicolas later will go into much more detail on how to troubleshoot and find out where that is. So thanks. But more to come, right? So MTQ was introduced, hierarchies were introduced, V12 high availability. The REST
Yeah.
API was introduced. That gives you a great tool to, record traffic between your client and TM1 itself. I was working on a reverse proxy that actually creates postman collections that you can then automate to run as well. So that testing. It's many tools, many ways, but you gotta find the right approach and get started and look at the bottlenecks that you might encounter. Back to you, Steve. Or James, sorry.
Yeah, just to kind of jump in there, sorry. Yeah, and I think it's a really kind of good point around, starting off with that 952 kind of like, and that kind of great breakthroughs there. And that's kind of interesting. That's when I started my Team One career was on that version. And I guess, as you're kind of like throwing it to Steve there, I think it's, important to kind of say, what Guido was mentioning there is the evolution here of, the architectural and performance and just the ongoing and increasing kind of investment, the R&D and the scalability of the planning analytics platform. If we kind of look at where we are now in terms of the stability of the platform, compared to maybe where we were 24, 36 months ago, there, when there was the early releases, Steve, of Planning Analytics and V11, first introduction of Workspace, there was some stability challenges there, but very much kind of Planning Analytics on cloud or V12, the stability is really important. But I guess going back to the architecture, Steve, like as you said, you kind of look back to look forward there, and we see that from time to time in sites. And Nicholas, you maybe want to talk to this too, where generally speaking, there is maybe an overuse of large cubes, where because it was built in a prior era architecturally, so there's like maybe too many dimensions, too much being put into one cube, as opposed to kind of separating those cubes out to get better performance, and then also having a good user interface over the top that hides that complexity. Yeah? So the user doesn't feel that. Steve, you want to make a comment on that? And then maybe, Nicholas, to kind of share a bit about your experiences too.
Yeah, it's a really good point, James. And I think, beyond just the architectural thing and which part of your architecture, whether or not it's your user experience or it's a cube in the background or it's some process or something, you also need to kind of begin to go through the process of collecting the data in order to support what exactly you're looking at there, right? So like tools like Pulse, for instance, are really useful in that case because you're able to actually go out, you're able to, track the performance of some of these things. And I know, Nico, you have some stuff to show us relative to that. And same thing, right? You can go out and talk to your users. We're dealing with a customer right now who they're having performance issues on their front end. And part of the reason that they know that is because they asked their user base, right? The basic stuff that's out there. It's not necessarily high tech as the session is titled, but it's something that's really useful. And it's kind of going back to the basics and going back to the people that are doing that. And I know, Nico, you've been dealing with recently some of these issues with a particular customer that's out there. I'd love to hear your thoughts here and sort of bring you into this conversation around like how do you think about this? How did you go about handling this in this particular case?
Yeah, hi. Well, Nicholas, a solution engineer here at CubeWise, and to the point, Steve. I mean, it will generally depend, of course, each situation specific. We would love to have that magic criteria that fits everyone, but it's hardly the case. That's where we sort of implement our craft. And in certain cases where we have new it will depend on the size of the models. It will depend on how legacy they are, right? And in many cases, and it happened to, I'll talk to all Team One consultants, we probably seen our name in most of the rules or TI processes comments. I'm reading the names of the participants here, and I've seen your code, and you probably seen mine. And some of these goes to like 10 years ago, which is amazing, especially when we consider the materiality of our job. It's seeing something you did 10 years ago being there, it's amazing. But it also is an indicative that certain things were not modernized. And in many cases, it's perfectly fine because the way it works, it hasn't changed. But in many cases, it seems that we need to rethink a bit. In the specific case we were discussing previously was, what do we do with a client? There is a client that has a big model, and it comes from many years ago. It's not just one client; it's multiple that have that framework. And what we tend to do in those cases is do an initial assessment. I know It's super easy for a consultant, and it's generally a rule like, let's throw it, let's start again, let's modernize your application by throwing everything you've done and starting from scratch. But that's not really what either clients want, and nor is something we want to do, because it's a lot of work to do that. And in many cases, the craft that we can do is how can we make it better? Not from scratch. Anyone can do something better from scratch, but how you can take what the constraints you have and show you how to improve it.
That's a really good point there, like that change management. So, when you kind of go, for a lot of people who are on the call here, you've got existing Team One applications, and there's, a lot of really good aspects to those models, but there's also some edges there. Yeah. And depending on the age and stage and the maturity of that model, some of those edges are a bit more pronounced in certain areas than others. But how do you kind of go in and, modernize and move things forward in a meaningful manner, but also being mindful of keeping some downward pressure on change management? Because, as you said, you don't necessarily want to come in as like agents of change and start from ground zero. You do want to look to reuse, recycle, re-engineer as what some of all the really good stuff that you have. And I think that's what you're kind of touching on there, Nicholas.
Yep, precisely. And so what I'll do now is I'll share my screen. I do have it's a mind map of a CubeWise consultant, I would say. Let me pull that in. Right? Can you see my screen? Is it readable?
Yes, we can.
Perfect. Let me just make this a bit smaller. There we go. And so here is essentially, we get discussion a lot, like, hey, I have performance issues, right? Like my users are complaining. That's generally the first thing we hear. And so what we try to detail here is, what goes in our heads when we hear that, right? Like what is our thought process? So generally speaking, because this is coming from users, right? This is either coming from a UI. So in this case, we put parfait reports, generally speaking, because pull seems to be quite fast. It doesn't have everything is resolved on the web, generally speaking. So it seems to be faster. Or you could have a slow TI process, right? So those are generally, again, this is just a subset of it. There are many other ways we can go about performance issues, but this might be the primary ones. So what we tend to do here is, we start asking questions. And as I mentioned, this is a partial one. It's the full one is different. But when we start, this is where we start. We say, okay, are you running on-prem? You're running on cloud. You're running on cloud. Great. So when you say your reports are not working fast enough, what part of the reports are you talking about? Are we talking about the TM1 server taking a long time to produce the data, or is it parfait that it's rendering slowly? And the reason I have this sort of highlighted in blue is that's where polls come into really handy, right? So luckily, the customer I was working with does have polls, and this is something really useful for me because I know exactly where to go and fish for the data that I need in order to determine these two. And so if we can go, for example, with a parfait rendering side, right? So if parfait is rendering slow, what version are you using, right? We do find, believe it or not, many clients that still use 32-bit version of Excel, which when dealing with large data sets might be a problem. If you're connecting to cloud, how are you doing? We had some weird examples lately about Wi-Fi versus network. Wi-Fi being faster through VPN at home than being plugged inside your office with an Ethernet cable. So that's where things get really, really strange, and that's where we need more monitoring tools like Wireshark. Like we don't even use Parfait anymore. We can start hitting the server with REST requests directly from Postman or using TM1Py as we normally do. So then we can go, what happens if the TM1 server data, the TM1 server is taking a long time? Well, this is where we start getting into like the new things, or newish, because MTQ, believe it or not, it's been a while since it was released. So do you have it enabled, yes or no? If you don't, try it, right? There's a CubeWise article that actually IBM recommended me to read, which was fun, because we were in a call with IBM and said, to set this up, why don't you read CubeWise note about it? And that I was not aware that we had a ton. And this is essentially it, right? Let's start with 30. Let's incrementally go to 60. If you do have it enabled, what is taking long? Is it taking long to run? Sorry, is it running or is it waiting? If it is running, right? What type of data are you trying to pull? Is it rule derived? Then that's where we know we need to go and check for your rules. If it's consolidated, for example, what is the data beneath it? Are you using that lovely function that I'm pretty sure everyone loves, consolidate children? That takes a really hit in performance, right? So if that's the case, are you actually using it properly? Should you use a set function rather than a consolidate children function? So these are all, again, things that go through our mind. If it's running on wait mode, what is causing it to wait? Is it a chore that's running? If it's a chore that's running, could it be rescheduled? And if it can be rescheduled, this is where you use pulse. Find a quiet time. Find a quiet time in your server where things can run and not bother users while they're trying to retrieve the data. If it cannot be rescheduled, if it's the chore running one process, if it is running one process alone and it has to be at that time and it's blocking people from doing their job, then that's probably where you reach a critical point, right? That's where you need to reevaluate either the business logic around your model or the architecture around your model. If it's running multiple processes, is it running on single commit or multi-commit? And again, this is the red box generally we want to avoid. Right? We don't want to reach the point in which we need to start thinking about rechanging the architecture. We want to reach other places where we can actually make small changes to overcome these situations. But the reason I'm pointing this out is essentially because there's overhyped approach, let's just say that, of saying the problem is the architecture. You need to change your architecture. No, it's not like that. You need to bear in mind what you're doing. Ask these questions carefully, gather the data, use the tools that you have available to do that. And then if you end up having to go through a reevaluation of your architecture, at least you can show that you did your due diligence, and by inspecting all of these pieces, I think at this point in time, once you reach this, you know where to go and look and find the architecture change that you need.
And I think what you're kind of saying there in terms of like the architecture and the data collection there is really, really important, right? So, have that overused term, but there is a lot of truth to it, like data-driven decisions. Yeah, and increasingly the ability, a bit of a plug there for Pulse, as you said, as a way to kind of collect great performance metrics and some of these data. I know, Steve, you've been doing some, taking Pulse data and running them through LLMs to kind of see, do some Gen AI analysis on that as well. And maybe you want to talk to that, but getting the data, I think it's key. And I think as you see this kind of mind map, it's a subset. There's a lot more behind this. When you really kind of expand it, but there's just a subset of some of the thought process you want to go of, like, where are we having the performance issues, and trying to kind of identify that and what is the root cause analysis, and look to kind of resolve that. And then of course you maybe need to pop back and kind of architecturally look at things, but again, kind of trying to have more of an incremental kind of approach to certain aspects of your modernization and performance as a first step. Steve, what do you think?
Yeah, no, it's a really great point, right? And I just want to point something out here that Nico also mentioned within this that I think is also really something you really want to think about, right? So, the configuration and the database level parameter changes and things that you can adjust, right? MTQ, as you mentioned there, right? They can be really powerful as you go and sort of scale them up. So back to something you mentioned there, James, around sort of the data collection exercise and some of the things that we've been doing with Pulse and the Gen AI stuff, right? That's one piece of the puzzle. Right. So that really gives us a lot of information really around the database, what's happening on the back end on your TM1 server side. But there's also, as Nico alluded to there, relative to the PAF-A side of things, performance is really governed and derived by the experience of the users, right? And depending on how you have your users sort of interacting with the system, whether it's through your VPN or through PAF-A or through PAW or through whatever the tool is, there's a lot of variables that go into that, and there's other things that we kind of would need to do and tools that we might need to bring into play. And I know, Guido, you have some experience with some of these. I think you mentioned Load Runner earlier and some of these other ones. Right? These are tools that can help us collect even a broader view of data in order to put the complete picture together. Because to Nico's point, right, you don't want to be going down a path of re-architecting something because you have a poor performance issue. You don't want to be going down the path of putting new infrastructure in place when you don't have all of the data, right? You want to have the complete picture of this and do those real data-driven decision making. And Guido, what are some of the tools you use and have been using over the years in order to support this? Can you talk a little bit about that?
Before we get into tools, I just want to add a comment to what you had just mentioned. So there's other factors that can influence performance, right? Let's say you have a large some database engine running on the same machine as you run TM1. That's a bad idea, right? So you want to make sure that your hardware is up to spec, you have enough processors, enough threads available if you do multi-threading. So Pulse can help you, detect bottlenecks in your model itself. But if you go down to like the hardware level, memory, etc., speed, I myself am a gamer. I'm overclocking my CPUs, right, to get more performance out. So do I want to upgrade my hardware to make things faster? Networking can be an issue. And so many factors, right? What Nicholas mentioned earlier with being on Wi-Fi or on the network doesn't make any sense. So you need some other tools, right, to identify and isolate those things. Now, going back to the tools, to your question, Steve. So I was mainly working. So the most time I spent was with LoadRunner. No doubt about it. But it's expensive and it's complicated, right? So you do record your web traffic. We again used T1 Web back then. You get like scripts, recorded interactions between the browser and the web server, and then you have the ability to play that back. But you have, starting when you log in, you get a session ID, right? So you need some code in your load runner scripts to grab that session ID and then basically catch that from the response from the web server, right? When you rerun the scripts. And then it comes to this discussion about the activity itself. So how do the users interact with TM1 Web in this particular case, right? So you get like profiles, right? So you have somebody who's writing back, someone who's looking at higher level data with different element selections, right? So you need to basically make this matrix that determines who's logging in, which web sheet gets opened, which elements get selected. Then you can measure the calculation time, right? From when you sent the request to when the response came back. And then you have a discussion with the customer. Hey, so how often does the person do that, right? It's not like you do this every second. You open the web sheet and do these actions every second. Once you have your elements selected and you do your calculation, you usually take some time to look at the results and analyze them, right? So that's called think time or wait time, right? And then you close it. There's lunch break, whatever. So you have a discussion with how many times do you think this analyst performs this action during a day, right? And then you adjust your parameterization. It's a difficult word. Accordingly, right? So and then you run it. You look at the activity on your TM1 server. And then again, you have something like Pulse that can monitor that interaction and find out if there are bottlenecks in your model itself as well. JMeter is a very common tool out there as well. Again, there are some custom things you can do. What I mentioned earlier was Postman, that you basically record just REST API requests and play them back. But to your point as well, Stephen, the user is really the should be the focus, right? I mean, there's load processes. How fast can you load your data into the model, etc. But when the user clicks a button, how long does he or she have to wait until the response comes back, right? So there's report design, there's the strength of the model, there is some infrastructure considerations. So as I mentioned earlier as well, it's complicated, right? So you have to really put some thought into how you approach your performance testing. And then there's unit testing as well, right? Stephen, you were going to mention test center, I think at one point in time. We'll get to that.
Yeah, that's a great point. So Test Center is a great tool. It's a part of Arc. So if you have Arc, you can go and use it, but it allows you to or I guess Arc Plus. Oh, James knows which one it's in. I can never keep it straight. But it's a new feature in Arc that allows you to be able to sort of do some automated and standardized unit testing for your models. And that's a great point, Guido, right? Because you want to be able to test these things repeatedly and have a structured way of defining, right? Just like you're doing with JMeter and Load Runner, but from the TM1 interface side, that if you're going through and you're making changes, whether or not they're configuration changes or otherwise within your TM1 model in order to provide better performance, that you're not breaking something, right? That you're getting the same results just faster, right? And I guess, I don't know, from my perspective, that's a lot of stuff that you were talking about there, Guido, around tools that can really help to really go after the broader components of sort of a TM1 instance, a planning analytics instance. But I guess that sounds like a lot of infrastructure, right? It sounds like a lot of things you got to set up. What if I just want to get my TI processes to go faster?
Right. So just to add one more point, I'm so sorry. And as you may be able to read between the lines, there's no one size fits all, right? So performance testing is usually a very custom exercise. Sorry.
That's okay. So how I'm going to go back to that question, right? Because I'm sure everybody on the phone is sitting here and saying this is all very cool, interesting stuff, but tell me how I can just get my stuff. I don't want to re-architect everything. I know things are slow. I have a data load that takes forever. How do I make it go faster? Nico?
That's my cue, isn't it? Yeah. So I mean, in those regards, I mean, EC is part of this, right? So how do you get your TI process to run faster? So if I go a bit more to the mind map on the other side, this is the part where things blow up a bit. So this is the interesting piece, right? So are you the processes that you're running, could they be multi-thread or not? Are you actually using? Because the main reason is if it goes fast, it means it's taking a long time. And if you have the hardware on the back end, are you actually using it? We've seen many customers buying either by themselves a huge expenditure in servers, or getting them from the cloud with like hundreds and thousands in terms of RAM, tons of CPU power. And when you see them, they're just using one. And that's where we come in, and that's the part where we can do our magic. So when it is when it's not multi-threaded, right? This is the part we need to start thinking about this. So assuming we can multi-thread this, and to be clear, multi-threading essentially is the end result for you as a user will be the exact same. You're only just going to get there faster because you're going to use more horsepower that we assume you have on your server, right? So there are many paths in here to get that, right? So we do, as you know, have a product which is open source, which is called RushTI, and that's generally the framework where we implement multi-threading, right? There could be, we also have a tool called OptimusPy, because multi-threading, and without going to the really technical detail, but just bear in mind when you do multi-threading, right, you're going to be most likely attacked like multi-threading by a specific dimension. So an obvious case is you want to load your 2024 actuals, and you don't do it all in one thread. You divide it by 12, right? You get 12 different files or 12 different queries, and you load them in parallel because they're all independent, and that's pretty much it. But it's really important in many cases to understand the granularity of your data and also to see where that is. There's another tool we have, which is also open source, which is Optimus Pi. And Optimus Pi, what it essentially do is it will reorder, it will give you a hint on whether your dimensions are in the proper order. The order from an internal standpoint. So you can change the dimension order and nothing will happen to your code. The cell puts will remain in the same order. It's a free of code improvement, right? There are no code changes in this. It takes a while generally to run because it has to do a lot of computation, but in essence, you're going to get a better performing cube that can multi-thread better, right? Once you get that, you're going to be able to see that. And then once you have that specific ordering, then you can use RushTI to say, okay, I'm going to load all of these 12 files for my yearly sales in parallel. There's one more catch to this, and it's the other piece, right? Hey, I'm already multi-threading, right? So, and I still have problems. There's a whole lot of things to actually review when that happens. So this is the part I don't want you to get disappointed. There's no one solution. There's no click, right? But there are many things that you can do, right? Because multi-threading is also a craft. You need to know where you're multi-threading, what is your data type, where is it actually taking long? Is it taking long on the prologue, on the metadata, on the data, on the epilogue? Are you using all of your variables? So this could go on and on and on and on, right? It's when you look at the big picture, what we were discussing, and these are not even all open, it's a big mind map, right? So there are many things to consider when we do this sort of analysis, and we have this on our end as well.
And just on that multi-threading thing, like, and when we're talking about that, having the opportunity to work with some really fantastic large organizations in particular globally, and so some notable ones in the US. The data movement size can be substantial. Absolutely very substantial. We talk about businesses that are multinational. So you've got users in London, Sydney, and in New York. So your quiet window is very hard to find, if not maybe even impossible to find at times, depending on how it's deployed. And again, sometimes we're going in, and there's already as Steve said, like and Guido, there's already existing infrastructure set up. There's already existing kind of core architecture set up that you want to improve as opposed to start again with. You want to kind of from a change management and perspective, you want to kind of try to keep that down. But in terms of the multi-threading, in our experience, and we've kind of brought the lessons we've learned, it can be very advanced. And when you kind of like you're kind of doing it at the edge, and that you want to that performance improvements, that craft there can then kind of be is applied and can be applied to smaller data sets and to increasingly get that high performance data movement, which I think is it's a great topic, as Steve and Guido said. Performance generally is such a broad discussion. Is it the network? Is it your home internet? Is it and things of that nature? Is it the calculation speed of the Team One engine? And when we're kind of wanting to do here is, and maybe you want to touch on here, Steve, like the RushTI as well. How do we just move the data quickly between the cubes, as an example? How do we move data quickly within the engine? And RushTI, and let's talk about obviously RushTI and what's coming up as well.
Yeah, it's a great point, right? So I know, Nico, you've done some work on RushTI recently and have some things to show here, but I don't know if you can maybe take us through sort of an example of RushTI and how it has worked and how some of your new techniques maybe can help to make things even faster with RushTI and the future of RushTI.
Sure. Yeah. So, I mean, to go back to the point, right? If what we've seen in many cases is that when the process that is sort of the problematic one was not run multi-threaded, we did implement a classic version of RushTI, and we go from 8. I'm not lying, and I know that some of you are here, so you can also say it. From 8 hours to 4 minutes, right? From 10 hours to 10 minutes. It's amazing what you can do, especially when you have that power muscle on the back end. But there's also like a thing, yeah, I'm already running multi-threaded and it's still taking long. So what do you do? And that's where the point where again, our craft comes into play. So let me show you something here, right? So this is something that we build on top of RushGI, right? So RushGI is true that it run, in this case, for example, executed more than 1,000 processes, right? And this is the average duration of the process. And we ask it to run with a 50, a topping at a 50, using up to 50 cores, right? And you see all of this is fantastic, 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 fantastic. And then what happens? It stops. And for like, what is it, almost 40 minutes, it just run in a single thread. So that means that, yes, you're multi-threading, but are you doing it in the proper dimension? And that's where you need to start rethinking about this, right? Because if you see, what do we have here? We're saying that from those more than 1,000 processes, 924 of them run between 0 and 200 seconds. Yet all of these outliers here, this one took, what is it? I can't see it here. Well, I can zoom in. There it is. It took, we can see that here, right? So this is the mean duration, and these are all the processes that go beyond that. And you can see here that this guy is to calculate an IRR function. This is the culprit. When we run it for this specific project, it just went ballistic. This is the one, right? So these is the type of analysis that you want to do when, even though you're multi-threading, there's more to do. There's always more to do. That's why James said you can never get fast enough. There's always things that you can do. As sparsity, you can keep it down, and things are running at the best, with the same level of duration. That's when you're going to know that you're hitting the proper performance.
It's a really good comment there about the, is multi-threading just as a general topic there, but then the craft and just the analysis and the experience with the models around which dimension, discovering the right dimensions, or depending on the cube, and there's a few variables here, where to run it on. And I think that's something myself I've learned over the last, working on this for very much so over the last, started like 5+ years ago on this specific topic, on some really big data sets, on a particular project down there in Florida, where that learning of iterating and testing of running the multi-threading on different dimensions and the performance improvements, and it can change over time. Just because it's this dimension today, 6 months from 6 months on, your shape of your data might change. Just incrementally, where you want to retest, reanalyze, and re-optimize. Fair statement?
And don't make two changes at the same time. Do one change and test.
Yes.
And for people to understand it, maybe if it is too abstract, but you can think of it like, if you want to process IRS submissions, right, for 2024, you wouldn't distribute that by month, right? Because 90% of IRS submissions happen between February and April. So what's the point, right? You can probably parallelize it by gender, then you can parallelize it by state, maybe, and you can keep branching off and try to find those proper places where data is evenly distributed, rather than there's no point in if 90% of the data is in one specific subset of your dimension, don't paralyze for that dimension. It's not going to give you what you want.
But I think, Nico, there's I mean, this is an interesting problem, right? But how do we go from this sort of scenario that you're showing here? How do we solve this, right? Because you've got this extra long running process that's running at the end here, right? I suspect it probably didn't kick off first. It probably kicked off somewhere in there. Like, how have you solved this, right?
Well, that's a fair point. And I mean, in specifically for this case, there needs to be a bit more of an analysis, and we can, that's where Optimus Pi can help in and trying to tack the proper dimension. But it could still happen that even with a proper dimension, even using the proper pivotal dimension to do this, you're still not fast enough. And that's where the new version of that we're working on comes into play. So this is a bit of a preview of what's going to come tomorrow in the Atmosphere launch. We're going to be launching RushGI Pro. as a service, right? So you don't have to install RushGI, you don't have to have Python, you don't have to have executable. If you have Atmosphere, you're going to be able to launch this directly. And for the people who ask why the Pro, it's because, as you see, I'm an Apple person. So if things look too similar, the only way for me to differentiate is put a Pro at the end, even though they're practically the same. But anyway, that's a side topic. So anyway, what is new about this? And there are multiple pieces, right? So I'll try to go through, focus on the performance one, and we'll talk about more of the other ones tomorrow. As you can see here, this is a bit of a sample, right? Of a simple sample of what RushGI can do and where we're hitting a limit, right? So this graphic here basically shows six TI processes that I want to run, and you can see the dependencies between them, right? So the first one can run without any problem. The same with the third and the second one, but the fourth and the fifth are going to be run as soon as thread 2 is done, right? There's a dependency there, and the same thing happens with the sixth thread that is dependent on number 4. Now, the classic RushGI approach is essentially to include levels, right? And so I can't see it there. There we go. So the levels are essentially a way for RushGI to parallelize the processing, but at the same time, it sort of serializes it, right? Because it means that the processes that are running independently, that have no predecessors, are going to run first, right? They're going to be included in the first level, and any process that it's dependent on any other process from the level, from the first level, will be in level 2, and then level 3, and so forth, right? It's like a cascading piece. And though RushGI can execute all of these threads in parallel, the levels it cannot do in parallel. So that's a limitation. So in this example, for example, you see it took 14 seconds, right? The only thing this does is just wait. It doesn't do anything else. It's for illustration purposes. But the key thing is that since if you look at the thread 4, right? Thread 4 is dependent on 2 being done. So why, if thread 2 was done here, why the thread 4 had to run all the way here? And that's because RushGI, the classic version, uses the levels, right? So what we introduce with many other pieces in RushGI Pro is the ability to get over this, right? We're no longer using levels. We're using something called DAG, which we don't have to go through in details, but anyone familiar with Airflow and how Airflow tracks dependencies, it's the same concept. It's a sort of mathematical concept. And we sort of implemented that inside the new version of RushGI. So now the exact same process, the exact same set of processes that you have are going to be executed in half of the time. And I want to be clear on something. RushGI is not going to make your single process run faster. It's going to make the entire orchestration run faster because it can handle the dependencies much, much better. And this is the sort of the example of it. Is that what you were thinking, Steve?
Yeah, exactly. And I think, you hit the nail right on the head there, Nico, right? RushGI can make fast things go even faster, but isn't going to make slow things go any faster. So I really appreciate that. And, it's a great topic. And I think bringing it back to the beginning of you got to have great architecture to make things go really, really fast. Right, James?
Exactly.
Yeah, and it's a good call out there. And then thanks, Mike, for the shout out in the chat. Nice to see there's a few people kind of loving the session, and Nicholas and Steve and Guido. I guess, but what about some of the stats you've got there? So, I mean, this is going to be, we're going to dive into this even further with Marius tomorrow, because as we said, this is part of the Atmosphere, I guess, offering set. But this is what we're seeing, huge, great performance improvement, which kind of, can really, again, the faster we can move that data, and then effectively what we're trying to do is to improve and help the end user experience. We want more user trust, help with the trust of the user experience, the adoption of the application, just the general positive feedback around Planning Analytics is an excellent application at our organization that is growing, that is thriving. They're the things that we want to achieve, and so performance is one of the metrics to kind of get us there. So what do you have on screen here to kind of demonstrate facts about what we're saying here, like evidence?
Yeah, so this is essentially the same. One thing I didn't mention is like if you have a task file today that you build, the same task file will be usable for Rush Pro. This task file is the exact same. The only thing we added were more something I wanted to do for a long time ago, which was to have a CLI client for Rush TI. So now it can take parameters a bit more dynamic. But in essence, here you're running the same thing, and you can see here that the same threads were run and they were called. The overall process took 19 seconds, whereas the new one took 8 seconds, right? So it's much faster. And the reason why you don't see the same values as in the overview is because again, there's always an overhead when you multi-thread, and that's always something to keep in mind. Even though we're asking it, for example, to wait for 2 seconds, we can catch it using the REST API 2.9 seconds right after. But as we go to this process of re-architecturing, that overhead is now much lower than lower than it was before.
That's pretty. That is some pretty impressive stats there.
Yep.
And kind of, and I guess it goes without saying here, for people who are kind of like listening and interested in this and want to take an early step on having a look at this, please definitely turn up to the Atmosphere session tomorrow. We're going to dive into that. But yeah, reach out to your local QBuy's office and let's kind of let's discuss it. And we're going to be very proactive to some of the customers who are already using Rush TI and talking to them about can we engage with them, proof of concepts, proof of technology. Kind of let's start putting this in place and to demonstrate that performance improvement, because there is some great numbers there. I'd say that.
Yep. And another topic, a small piece on the Rush TI Pro piece, is that many of the complaints or recommendations was, I don't know what Rush TI is doing. So Rush TI can now produce this, like this silly sample that you see here. This is not an Excel chart. This is, you can actually ask for it. And before even running anything, you're going to get the full-blown picture. Now, if you use Rush TI to run 1,000 processes, bear in mind this is going to get really ugly. But you will be able to track every single thing, every dependencies, every parameter, everything. So there's the ability to produce these dashboards, like the one that I shared before, to analyze concurrency. That's all going to be included in Rush TI Pro.
Excellent. And there's a good question there about whether Rush TI Pro is going to be open source, and it'll be part. And the answer is Rush TI Pro will be part of Atmosphere, and Atmosphere is a licensed software offering from Cubewise. So just to kind of say that, well, Rush TI currently is open source and free to download. Some of the chats there that Steve shared earlier, they can kind of get access to that and kind of reach out if you need some hands with configuration. Love to help out there. But yeah, Rush TI Pro will be a commercial offering through Atmosphere. And we're just kind of coming up a little bit on time here, team. And I know we've talked a bit about data decision making and Pulse. Maybe just kind of like layer it on here just before we kind of close it out, Nicholas. How would you kind of like also look at this from a Pulse perspective? Again, we want to capture the data and the metrics. We obviously want to test something that Guido talked about before with some of the new innovation coming out of Pulse and Arc around the ability to do more automated unit testings. And then we're looking at, on a roadmap perspective, automated reconciliation testings, and start looking at like automated performance testing. So we're doing a lot of investment in the Pulse and Arc offering to kind of, again, help developers be more efficient, more productive, have a better just general developing experience. But what can you kind of just add briefly around like Pulse as it relates to kind of Rush TI and just some of these metrics here as we close out?
So I think one of the key things is that, whether you use Rush TI or you use your own custom, as orchestrator using run process, whenever you want to multi-thread something, you need to be extremely mindful of the impact that it's going to have on users, because, 3 processes is fine. 1,000 of them can be, and this could get, we had clients that have like a data pipeline, for example, that go from like extracting from Snowflake to putting to a staging queue, then going through input, and like tons and tons of them. And that might have an impact on users, right? And that's part of what we did with the MindMeister piece that we talked earlier. So Pulse is going to be really helpful when you can see in the user reports, like how if users are being hold on wait and the root cause of it, right? That's extremely important. If you have Rush TI running through a specific user, or even Rush TI plane, Pulse can show you where Rush TI is being run. It will show you the sessions, and it will show you if it's causing other people to wait. So this is really important when you introduce multi-threading into a system. Ideally, when you do this, the process that was taking 30 minutes is now going to be narrowed to 2 minutes. So maybe users will only wait for 2. But even if that's the case, that's where you go and make the extra effort of seeing, is it actually causing a lock? And along with Pulse is Arc. Arc is super capable. Pull has now debug capabilities, but the debug capabilities in Arc are just much, much better. And using Arc, you can see where all of these processes are actually causing other, what is the locking that is holding that cause regular users to have to wait, and you can work from there.
Yeah, it's a really good call out there. It's a fair statement. Yeah, Paw does continue to kind of evolve and mature as a platform, which is great to see. And their CubeWise, with our suite of tools, again under the CubeWise Code banner, there to help people on the call, with their productivity. Yeah, in terms of delivering better, faster, stable, more functional, more usable, maintainable systems. So yeah, it's a fascinating topic, this one, and I think it's the ability for us to kind of step in and kind of demonstrate to you these kind of performance improvements. We really welcome that opportunity here from the CubeWise team. I know, Steve, anything you want to kind of close out here, especially as we look towards tomorrow? I think as we wrap up, yeah, I mean, as part of the engineering team, what would you like to add just to close out?
Yeah, no, I'm really excited for tomorrow's session on Atmosphere here. Marius is going to be in the house, and we always love talking to Marius. I think that there's a lot of capabilities that you'll be able to see within the Atmosphere tool tomorrow. And so I'm excited for the release of that. There is one question here, Nico, just to throw to you quickly. Rush TI versus synchronization on your TI processes. Why would you go Rush TI versus TI-based synchronization with run process?
It's a good question. There could be, the main reason why I would use Rush TI, for me, it's clear and it doesn't require like the keeping tabs on what is being done and keeping that outside your model is going to help you, I think, a ton to prevent any locking, as we've seen in many cases. It's really hard to keep control of your applications. If you're running V12, now IBM included like the feedback for the run process function, so you can actually see if it's running or not. But playing with synchronization and global strings and acquiring locks, it can be done. It's a lot of work that is actually being done by a tool already that you can download, and it's free. So why would you go one way or the other? If you inherit a model and you like it and it works, great. But if you're going to start from scratch, this is already built. And if anything, you want to load part of the Rush TI log into a cube at the end, go ahead. But
and it's field tested, right?
Yep.
Yeah.
That's one other aspect.
Yeah, it's a fair point. I guess the build versus open source download buy kind of argument. In terms of the product, the product offering, the testing, the documentation, and also the evolution of the products as well. As you can see here, if CubeWise going, the CubeWise performance improvements here around Rush TI to Rush TI Pro, like those enhancements to the benefit of the users that are using the software, which is nice. All right, gentlemen, listen, we are up against time here, and I think we're going to kind of wrap. So a big thank you to Guido, Stephen, and Nicholas to kind of join us here, part of the CubeWise engineering team. I know a lot of you work with them already, but just as a big thank you for all of you kind of jumping on the mic today and kind of starting to again look at some of the innovation and technical leadership we have as it relates to performance, in specifically some of that data movement within planning analytics as an example, but also that kind of like just stepping back and talking about the performance can kind of be quite broad, right? It can be quite a broad topic, but we just want to kind of narrow it down to more of that kind of Rush TI, TI movement kind of conversation there. And again, also just kind of being mindful as well when we're kind of talking about these topics about your architecture, starting off incrementally. and kind of doing, the best we can with what you currently have, and trying to optimize that, and then from there, if you think of your analytical roadmap, it doesn't necessarily matter where you are on your kind of analytical journey. What matters is that you're kind of more moving forward. Yeah, you need to continue to move forward with the technology and evolving. And sometimes that can be, small steps. Sometimes that's bigger steps. But again, there's that opportunity, as Nicholas mentioned there, of like coming in, doing design and discovery, understanding where we can improve things, with being mindful of the change management aspect. But again, also, as you kind of mature and grow forward, maybe there are some architectural changes that are advantageous that take a bigger lift. But again, with the right planning and execution, these can be, extremely successful. So that's a bit of a wrap. And as we said, tomorrow we'll be wrapping up CubeWise Innovation Week 2025 with the launch of Atmosphere. So really looking forward to everyone joining us there. Thank you for the great questions. We'll be following up on a few of them. So thank you on that. And I hope you have a really enjoyable rest of your day. So thank you for your time. Thanks.
Thank you.
Bye.
Hey.